Hello everyone, good morning. I'm audible, right? Good morning, good morning. Yes, good morning. Yes, thank you, thank you. So, hello everyone, welcome. So, we're going to start a new journey for UPSC Mathematics Optional 2024. So, we're going to start first chapter in paper 1 is analytical geometry, right? So, by syllabus, the first chapter is linear algebra, but since many are um, been requested to start analytical geometry, we are starting analytical geometry as our first chapter, right? So very easy chapter. Um, in YouTube itself, we have completed many chapters, and in an academy also, we have completed many chapters. But no problem, we will do all again, right? We will do all again. So we will start first with analytical geometry, right? We will start first with analytical geometry, and in the community section as well as in Telegram, I have given you the last 15 years analysis, that is previous year's question trends on analytical geometry, right? So I hope you have seen that. So first part we will do is this is lecture 1, and first topic is direction cosine and direction ratio. This is lecture number 1 of direction cosines and direction ratios, right? Okay. So when you see the syllabus, you can see this is syllabus, right? So very easy syllabus. So direction cosines and direction ratio, planes, straight lines, spheres, cone, cylinder, ellipsoid and hyperboloid, paraboloid, generating lines, general equations of second degree. That is 1, 2, 3, 4, 5, 6, 7, 8, 9. These two are same combined. So this is 10. So there are only 10 topics that we're going to cover in analytical geometry, right? So we are going to cover only, this is syllabus, right? So there are only 10 topics. Actually, these two are same continuation, right? Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So very easy. First, we will start with direction cosines and direction ratios. This is very important, right? Because this is the basic to understand planes and straight lines, right? So direction cosines and direction ratio understanding is very important to understand planes and straight lines, right? So this is the image that I have already uploaded in community section as well as in Telegram group also. This is the previous years, last 15 years trend analysis. Blue is for IFOS and red is for IAS, right? Blue is for IFOS and red is for IAS. So we can see in direction cosines and direction ratio, there are 4 questions in the last 15 years only from IFOS, not in IAS, right? But don't think that we cannot expect a question in IAS, right? It is not like that. So when you are studying for a IAS exam, you need to practice IFOS questions also. That is very, very, very important, right? You need to practice IFOS previous years questions also, and also UPSC IAS previous years questions also. You need to practice, right? No problem. I will be doing all those problems, right? So you can see by similarly, I have given you all the last 15 years analysis, and you can see in every year you can see you can expect 4 to 6 questions from analytical geometry, right? So if you want to analyze more, I have already uploaded this in community section in our YouTube channel as well as in Telegram channel, right? Okay. So first we will be starting with direction cosines and direction ratio. So I think it will go for 3 to 4 lectures. After that we will start with planes and straight lines, right? Yes, no doubt, right? So we will be starting with direction cosine direction ratio. We will be solving these 4 IFOS questions also in that process, right? Okay. So first we will start in this class, right? In this class, what we're going to do is we're going to introduce the definition of direction cosine and direction ratio. So we will introduce what is meant by direction cosine. We will introduce what is meant by direction ratio. right? And then we will see some notes, some important note based on direction, cosine, and direction ratio, and then we will do some problem based on that, and then we will introduce angle between the lines, right? So we'll be seeing many subtopics in this class. So your commitment and dedication is very very important, and you just take a new note, right? Have a separate note for analytical geometry. Just follow my notes, practice the questions that I'm giving. You can do any problem that I'll assure, right? Okay, so please make a fresh note for analytical geometry, right? Okay, super. So there is no any prerequisite required, right? You just follow the lecture, you'll understand all, right? It is not that you have to be good in maths, bad in maths, you have to be topper in maths. It is not like that. Just understand the video, you will be very easy to follow, right? Okay, so we'll start. No doubts, right? No doubts. Okay, yes. So we'll start, right? So first, what we'll do is, I have changed the screen to green color. Is it okay, right? For the last 4 to 5 classes, I have done in black board. Now I changed to green so that you will have some clear vision, right? Okay. So first, what we will do is we will define what is meant by direction cosine of a line, right? So for line only, we'll talk about direction cosine and direction ratio. Okay. So first, and everything is 3D. Everything here is three-dimensional, right? Everything here is three-dimensional only. Okay. Okay. So first, we will define what is meant by direction cosine of a line, right? Direction cosine of a line. Right? So we will introduce what is meant by direction cosine of a line, right? Okay. So everything we will be talking only in 3D space. Everything we will be talking only in 3D space only, right? Okay. So let us have a three-dimensional space, right? So this is our x-axis, this is our y-axis, and this is our z-axis, right? So we have a 3D surface, right? So consider a line AB. So consider a line AB, right? So we have a line AB, and I say this is our line AB, right? Or line segment, right? No problem. So consider a line segment AB, right? So we need to find the direction cosine of this line, right? We need to find the direction cosine of this line. We will introduce what is direction cosine also, right? No problem. So in order to find the direction cosine of this line, what you have to do is you just need to draw a parallel line that is passing through origin, right? That is, in order to find the direction cosine of this line, draw a line that is parallel to AB and passing through origin, right? So draw a line that is parallel to AB, right? Draw a line parallel to AB and and passing through passing through origin, right? So I'm going to draw a line that is parallel to AB as well as it is going to pass through origin, right? So this is the line, right? This is the line. So you can see this is parallel to AB and also passing through origin. So this is our point O. Let us take a point P in this line, right? Let us take a point P in this line. Very simple. We have a line AB. I'm drawing a line that is parallel to AB and passing through origin, right? This is a line only, right? This can be extended, right? This can be extended also, right? So we have a line AB. We have drawn a parallel line that is passing through origin and parallel to AB, right? Okay. Let alpha be the angle. Let alpha let alpha be the angle made by the line OP, right? So this is a line OP. So alpha be the angle made by the line OP on positive x-axis, right? Let alpha be the angle made by OP on positive x-axis, and similarly let beta be the angle. Let beta be the angle made by OP on y-axis, right? On y-axis. So this is our angle beta. Right, very simple. We have a line. It is making an angle alpha with x-axis, beta with y-axis, and let gamma be the angle, and gamma be the angle made by the line OP on z-axis. All are positive axis only, right? Positive x-axis, positive y-axis, positive z-axis. On z-axis. So this will be our gamma. Right? So we have alpha, beta, gamma. Those are the angle made by the line OP, on positive x-axis, positive y-axis, and positive z-axis, right? So these alpha, beta, gamma are called the directed angle. The angles alpha, beta, gamma are called the directed angles. So we are going to call this as directed angles. Right? So very simple. We have a line AB. I'm drawing a line that is parallel to AB and passing through origin. And this line makes an angle alpha, beta, gamma with x-axis, y-axis, z-axis respectively. And these alpha, beta, gamma are called directed angle. The cosine of these directed angle, the cosine of these directed angles. I'm taking cos of alpha. That is, I'm taking cos of all three angles: cos alpha, cos beta, cos gamma. The cosine of these directed angles, the cosine of this directed angle is called the direction cosine of the line. Is called the direction cosine of the line. Right? So therefore, what is the direction cosine? Cos alpha, cos beta, cos gamma. So this is our direction cosine of the line. Very simple. Whatever line you have, you just draw a line that is parallel to that line and passing through origin. And alpha, beta, gamma are the angles that are made by OP on XYZ axis. Take cos of these angles, that is called direction cosine of a line. We will always represent this as L comma M comma N. Right? So L is cos alpha, M is cos beta, and N is cos gamma. That's it. So this is the definition of direction cosine of a line. Very simple, right? You can able to follow, right? So we have angles. You are taking cosine of these angles. That is called direction cosine of the line OP. Direction cosine of the line OP. So no doubt, right? The cosine of these direct angles is called direction cosine of the line. We will always represent this as L comma M comma N, right? So L is cos alpha, M is cos beta, and N is cos gamma, right? Okay. Now we're going to infer three things now, right? I'm going to give you three note now. So note one is, so we will have three notes now. So note one, if L comma M comma N is the direction cosine of a line, if L comma N M comma N are the direction cosine, see from now on I will write DC only. If L comma M comma N are direction cosine of the line, right, of the line, then L square plus M square plus N square is always equal to 1. What is LMN? L is cos alpha, M is cos beta, N is cos gamma, right? So first notice, that is, if you square it up and add it, L square plus M square plus N square, it is always equal to 1 only, right? So we will see the proof for note 1. So what is L? L is cos alpha, M is cos beta, N is cos gamma. Okay, so we will prove this, right? So what we need to prove? What we need to prove? So we need to prove L square plus M square plus N square is equal to 1, right? Okay. So what is L? We know L is cos alpha, M is cos beta, N is cos gamma. Okay. So we will do this very easy. So we have our x-axis, we have our y-axis, we have our z-axis, right? And we have a line OP. This will extend, but I'll restrict to O, right? I'll restrict to P. So this makes an angle alpha, right, with positive x-axis, right? Okay. Now we'll go on and on, right? So we'll go on and on. Now what you can do is you just form a right angle triangle here. Just form a right angle. Let us say this point is x comma y comma z. This is a 3D surface, right? So any point will be some x comma y comma z. So let OP be the line. Let OP be the line, and let us take P point to be x comma y comma z. X comma y comma z, right? Okay. So what we need to prove? We need to prove L square plus M square plus N square is 1. Okay. So we will do this. Now what is L? What is L? L is cos alpha, right? Cos alpha. Now what is cos alpha here? Just form a right angle triangle here. So cos alpha, cos theta is adjacent side by hypotenuse, right? Adjacent by hypotenuse. So we'll have cos alpha to be adjacent side divided by hypotenuse. So this is our opposite side. This is our adjacent side. Now this point is x comma y comma z. So this is in xy plane. So that means this distance is x, this distance is y, right? Very simple geometry, right? This point is x comma y comma z. That means it moves x units in the x-axis, y units in y-axis, right? And z units in z-axis. So as of now, we have adjacent side to be x, and what is this is our hypotenuse, and this distance is modulus of OP, right? Modulus of OP, because if you take the distance formula, you will get the distance, right? Okay. So adjacent by hypotenuse. So adjacent side is x divided by hypotenuse. Hypotenuse nothing but length of OP. Length of OP. Now what is length of OP? So we have 0 comma 0 comma 0 is our O, and the P point is x comma y comma z. So distance between 2 points, square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So we have x divided by, so length of OP is square root of x square plus y square plus z square, right? So square root of x2 minus x1 whole square, x minus 0 whole square, x square, y minus 0 whole square, z minus 0 whole square. Very simple, right? Distance formula that we come across in 9th, 10th standard. So this is our cos alpha. Now similarly, what is your M? M is cos beta. So now this is our cos beta, right? So beta will be somewhere around here. Beta will be somewhere around here, right? Because beta is the directed angle made by the line OP with y-axis. Now you form right angle triangle here, right? Just form it. Just see the reverse, right? So we have right angle triangle here, right? Okay. Now what is cos beta? Adjacent by hypotenuse. Again, cos beta is adjacent side divided by hypotenuse. Now this is our adjacent side, right? This is our adjacent side, and this is our hypotenuse, right? Because we have angle here. So this is nothing but y, because we are moving y units, right? This point is x comma y comma z. So this is y. So our adjacent side is y now, and similarly hypotenuse is same. Hypotenuse same only, right? Okay. Same. You just see the triangle here. This is our adjacent side. This is our opposite side, because the angle opposite is opposite side, right? So we have angle here. This is our opposite side. This is our adjacent side. This is our hypotenuse. Adjacent side is this. This is nothing but y. This is y, right? Because that point is x comma y comma z. So this will be y divided by root of x square plus y square plus z square. Now similarly, what is n? N is cos gamma. So again it is adjacent side divided by hypotenuse, right? Now it is hard to visualize. This is a 2D plane, but we are drawing 3D surface here. Similarly, you need to form a gamma. For that, you need to make a right angle triangle. You will have z divided by OP. So it will be z divided by root of x square plus y square plus z square. Right? So we have found LMN. Now we need to square it up and add it. So therefore, what about L square plus M square plus N square? So L square is x square divided by, say by square, we will have root will be vanished, x square plus y square plus z square, and M square is y square divided by x square plus y square plus z square, and N square is z square divided by x square plus y square plus z square, which is equal to 1, right? Base is same, so you can add the numerator. X square, sorry, denominator is same. So x square plus y square plus z square whole divided by x square plus y square plus z square. So we will have L square plus m square plus n square is equal to 1. This is our first very important note. So if from this what you infer, from this what you infer, right? From this what you infer. So we have from this what you infer. That is the very important thing now, right? That is the very important thing now. So we will infer one thing from this. So note 2. Note 2. Okay. Note 2 is if L comma M comma N is the direction is a direction cosine of the line, then very important note, then Li vector plus Mj vector plus Nk vector is a unit vector along the line. It's a unit vector along the line. Very, very important. If L comma M comma N is a direction cosine of a line, then Li plus Mj plus Nk vector is a unit vector along the line, right? Very, very easy. So what it says is, very easy to understand, right? So we have a line, right? This is our x-axis, this is our y-axis, and this is our z-axis. Now let us draw a line, right? Now what is the direction cosine of this line? It is L comma M comma N, which is cos alpha, cos beta, cos gamma. Now this magnitude can be anything, right? The length can be anything, but this vector, right? This vector. So this vector is L comma M comma N. So this vector that is from origin to L comma M comma N will always be a unit vector along the line. That is this. Why this is a unit vector? Now what is the length of this line segment? Let us say this point is O. Let us say this point is S, right? Now what is the length of that line segment? It is length of OP. So it is square root of x2 minus x1 whole square plus y2 minus y1 whole square, z2 minus z1 whole square. And we know L square plus m square plus n square is always equal to 1 by the previous note. So that means the length of OP is 1. That means what? This is a unit vector because the length is 1, right? Magnitude is 1. So very important thing. So we have cos alpha, cos beta, cos gamma. You will have values, right? You will have values for cos alpha, cos beta, cos gamma. Yes or no? This L comma M comma N is a number. That is a coordinate in three-dimensional space. Because L is cos alpha, M is cos beta, N is cos gamma. So cos alpha, cos beta, cos gamma will be some number. It will be a tuple in 3D space. That tuple will always be a unit vector along that line. This is what note 2 says, right? Yes or no? So this vector is always a unit vector, very, very important, right? This Li plus Mj plus Nk will lie in this line as well as that will also be a unit vector along the line, right? Okay, this is our note 2. This is by note 1, right? By note 1, L square plus M square plus N square is 1. Okay, this is our note 2. Now we will find direction cosines of the coordinate axis, right? So note 3. So the direction cosine of the coordinate axis. Direction cosine of the coordinate axis. Direction cosine of the coordinate axis. There is some birds shouting outside, right? So please adjust with that sound. Okay. So direction, what is the direction cosine of x-axis? What is the direction cosine of y-axis? And what is the direction cosine of z-axis, right? So please repeat note 2. Yes, I'll repeat. Just a minute. See, note what note 2 says is if L comma n is a direction cosine of a line, then Li plus Mj plus Nk is a unit vector along the line. Very simple, right? So what is L comma m comma n? Is cos alpha, cos beta, cos gamma, right? So depending on alpha, beta, gamma, this will be some values, right? This will be some values. For example, let us say 1 comma 0 comma 1, right? Let us say this is 1 comma 0 comma 1. That means this will be a vector, right? That is I plus 0j plus k vector. So this vector is I vector plus k vector. This will be a unit vector along that line. That line magnitude can be anything, but that will be this vector is a unit vector along that line. That what note 2 says, right? Okay. Now direction cosine of coordinate axis, right? Now what is the direction cosine of x axis? See, for x axis, that is, if your line OP lies on x-axis, what will be our alpha? If this line OP lies on x-axis, this angle is alpha, right? If this line falls on x-axis, that will be the, we want to find direction cosine of x-axis. That means that line is on x-axis. Alpha will be 0. Yes or no? Because these two lines same lines, right? So alpha is 0, and beta and gamma are 90 degree. So we know these three are mutually perpendicular. These three are mutually perpendicular. That is angle between x and y and z, all are 90 degree only, right? So if this falls on, see, very easy. We have a line, right? So this OP falls on here. So alpha is 0, beta and gamma are 90 degree. Yes or no? For x-axis, your alpha is 0 degree and your beta is 90 degree as well as gamma is 90 degree. Very simple. Right? If this OP falls on x-axis, alpha will be 0. OP to y angle is 90 degree and this OP to Z why 90 degree? Because they are mutually perpendicular only. Right? So therefore, what is your direction cosine? What is your L comma M comma N? Cos alpha, so cos 0, cos 90, cos 90, right? Cos alpha, cos beta, cos gamma. So cos 0 is 1. So 1 comma 0 comma 0 is your direction cosine of x-axis. Is this a unit vector or not? Is this a unit vector or not along x-axis? That is what note 2 says. This is a unit vector only, right, along x-axis. So this point will be 1 comma 0 comma 0. This point is 1 comma 0 comma 0 and you can see that is a unit vector on the x-axis. That's what note 2 says. So even though this has infinite magnitude, but this point will be a unit vector on that line, right? Okay. And similarly for y-axis, what is your alpha now? So this OP, this is our angle beta, right? This OP falls on y-axis. That means beta will be 0 degree, alpha and gamma are 90 degree. So alpha is 90 degree, beta is 0 degree, and gamma is 90 degree again. So what about our L comma M comma N? Cos alpha, so cos 90, cos beta, cos gamma. So it is 0 comma 1 comma 0. Again it can see this is a unit vector along y axis, right? 0 comma 1 comma 0. Okay. And similarly for z axis, this OP falls on z axis means our gamma will be 0 degree, right? Our gamma will be 0 degree. So in that case, your alpha is 90, beta is 90, gamma is 0 degree. So your L comma M comma N is 0 comma 0 comma 1. L comma M comma N is 0 comma 0 comma 1. So again you can see this 0 comma 0 comma 1 is a unit vector along z axis. Is this clear? Up to now is this clear, right? So we have introduced what is meant by direction cosine of a line. We have introduced what is meant direction cosine of a line. So wherever line may be, you draw a line that is parallel to that line and passing through origin. And alpha, beta, gamma are the angles made by that line on x, y, z axis respectively. This alpha, beta, gamma are called directed angles. Take cos for that. That is called direction cosine of a line, right? And similarly, note one, what it says is L square plus M square plus N square is always equal to 1. So we have proved that. And that Li plus Mj plus Nk is a unit vector along the line. And we have introduced direction cosine of coordinate axis. So direction cosine of x axis is 1, 0, 0, and y axis is 0, 0, 1, 0, and z axis is 0, 0, 1, and you can see all these are unit vectors on x axis or y axis or z axis respectively, right? Okay, so direction cosine introduction is clear, right? Now we'll move on to direction ratio. We'll move on to direction ratio, right? So for line only we'll talk about, direction cosine and direction ratio, right? Remember that. Okay. Okay, now we'll introduce what is meant by direction ratio. Direction ratio, right? See, I'm going to put S here, right? Direction ratios. Instead of direction ratio, first I wrote direction ratio. Now I have changed to direction ratios, right? Okay, you'll understand very easily. Now you know what is meant by direction cosine, right? You know what is meant by direction cosine. See, let us take what is the direction cosine of x-axis. Let us give an example, and then we will come back to this, right? Now, what is the direction cosine of x-axis? Direction cosine of x-axis is 1, 0, 0, right? 1, 0, 0. Now, I'm going to write some more vectors. You just tell what is the similarity between these, right? I'm going to write down some list of tuples now, right? 2, 0, 0, 3, 0, 0, 4, 0, 0, 5, 0, 0, 10, 0, 0, and so on. So what you can say about this and this? What you can say about this and this? And similarly, suppose if you have a direction cosine like 1, 2, 3, right? I'm going to write down some list of tuples now. I'm going to write down some list of tuples now. 2, 4, 6, 3, 6, 9, 4, 8, 12, 5, 10, 15. Right? We have a direction cosine. For that direction cosine, I have listed out some tuples for this direction cosine, and for this direction cosine, I have listed out some tuples. Right? What you can say about yes, n times they are proportional. Yes or no? They are proportional to direction cosine. Yes or no? These list of tuples are proportional to direction cosine. Again, if your direction cosine is 1, 2, 3, this list of infinite tuples are proportional to direction cosine, right? If there is a tuple that is proportional to direction cosine, then that tuple means coordinate, right? Okay. If there is a coordinate that is proportional to direction cosine, then these are called direction ratios. Why am I direction ratios? Because it is infinite. Because it is infinite. Very simple, right? So any tuple that is proportional to direction cosine is called direction ratio. Yes or no? Any tuple that is proportional to direction cosine, then that tuple is called direction ratio. And very important observation is direction cosine is always unique. Direction cosine is unique because that is a unit vector. But direction ratios are always infinite because you can always multiply some k so that it will be proportional. That k will be some real number. Yes or no? You can able to understand? Any number that is proportional to direction cosine is called direction ratio. And very important thing is direction cosine is always unique. Cosine is always unique because there is a unit vector along that line. Right, very simple. Now you just observe with this diagram, right? So L, M, N. Now what about what about 2 times L comma M comma N? It will be somewhere around here, right? 2 times L comma N comma N. What about minus 2 times L comma M comma N? 2 times means you have to expand 2 times and then you have to reverse it because you have minus here. So minus 2 times L comma N will be somewhere around here, right? So this L comma M comma N is unique, but any multiple will be in this line only. Yes or no? If I multiply 2 times means the direction will not change. Only the magnitude will change. If I multiply 3 here means it will be somewhere around here. I'm making this 3 times larger, but direction will not change. If I multiply by minus means direction will change, but the angles will not change. Yes or no? Yes or no? See, we are just only enlarging or shrinking by multiplying some constants. If I multiply positive constants means we are expanding, right? If I multiply by negative 2 or negative 3 means enlarging and changing the direction. If I multiply by 1 by 2 means we are off, we are cutting off, right? Okay. So we will introduce a definition of direction ratio now. So you understand, right? So any number that is proportional, yes, collinear also because they lie on the same line. Collinear also. Okay. So if the direction cosine, if the direction cosine L comma M comma N are proportional are proportional to some tuple A comma B comma C, right? Are proportional to A comma B comma C, then this tuple is called direction ratio, right? So that means these two are proportional means we will write that as L by A, M by B, N by C is equal to some constant K. This is our proportionality constant. That is L is equal to AK. That is L is equal to AK. This not that is this therefore that is L is equal to AK, M is equal to BK, N is equal to CK. Right? So L by A plus M by B plus N by C is equal to K. Right? That is they are proportional. Right? Okay. Is it clear? Right? And there are two note now. I'm going to give note one. Direction cosine are unique. That is for a given line. For a given line. For a given line. For a given line. Direction cosine is always unique because that is a unit vector, right? We cannot have many unit vectors for a line, right? So for a given line, DC is always unique, but direction ratios are infinite. Very important note. So you can see, right? This is the direction cosine. So we can form infinite number of direction ratios. You just have to vary k. You just have to multiply some k here. K varies from k can be any real number, right? Okay. So for a given line, DC is always unique, but DRs are infinite. Now, how to find direction cosine if you know direction ratio? That is our next note now. What is my question? How to find we can find direction cosine. How? Make an angle alpha, beta, gamma with x, y, z axis. Take cos for those angles. That will be direction cosine. Now, if you know direction ratio, how you find the corresponding direction cosine? That is our next question now, right? So, note 2 is to find direction cosine if direction ratios are known. Note 2. So, to find direction cosine if direction ratios is known. That is, you know A comma B comma C. You know A comma B comma C. You need to find L comma M comma L comma M comma N is what direction cosine. You know A comma B comma C. Right? Very simple. Write on the formula. So L is equal. You just a minute. Just a minute. Yes. Now, uh, you see what you have to do is you just have to normalize this. That is, you need to make this as unit vector. Yes or no? You need to make this as unit vector. So this is a 12th standard max, right? How you make a vector as unit vector? 12th standard, 11th standard mathematics, right? Whatever vector you have, how you make that as unit vector? See, if you make these vectors, if you make these vectors as a unit vector, then that will be direction cosine. Yes or no? Because direction cosine is our unit vector. How you will make as unit vector? You know formula, right? In 11th standard mathematics, if you have a vector, how you will make that as a vector? A vector, a by modulus of a vector. Yes or no? This is a formula to make this as a cap. So we will write this as a cap. So a cap is equal to a vector by modulus of a vector. This is the formula that we will, yes, exactly, dividing by its magnitude. Dividing by its magnitude will make that as unit vector. This is a basic formula. Again, I am going to make use of same concept, right? Again, I am going to make use of same concept. So therefore, your L comma M comma N is, so your L comma M comma N is nothing but you know A, right? So A divided by what is the magnitude of this vector? If A vector is AI vector plus BJ vector plus CK vector. This is the vector notation. This is double notation. A comma B comma C is same as AI plus BJ plus CK. Now what is the magnitude of this? The square root of A square plus B square plus C square, right? This is magnitude, right? Very easy formula. So that means you have to divide by its magnitude. Square root of A square plus B square plus C square. B divided by square root of A square plus B square plus C square. C divided by square root of A square plus B square plus C square. So this will be your direction cosine of that line. So if you know direction ratio, you just have to normalize that vector to get the direction cosine. This is what node 2 is, right? This is what node 2 is. Is it clear? See, very simple. We have introduced direction cosine, and then we have seen three nodes based on direction cosine. We have introduced direction ratios. Direction ratios are very simple. Any number that is any tuple that is proportional to direction cosine is called direction ratios. Direction ratios are infinite. So if I normalize each vector, we will get unit vector that will be the direction cosine. That is what we have seen. Okay. Okay. Now, very important next topic. After that, we're going to do some problems. Very important topic now. Direction cosine of line joining 2 point. Very important. Direction cosine of a line joining 2 point. Direction cosine of the line joining 2 point. Direction cosine of a line joining 2 point. Direction cosine of a line joining 2 point. Right? Very important. See, this is somewhat similar to the first concept that we have seen, right? Just understand this. So we have our x-axis, we have our y-axis, we have our z-axis, right? So let us direction cosine of a line joining 2 point. Let us say A and B are 2 point. We need to find the direction cosine of the line. In the first slide, what we have done is we have drawn a parallel line that is parallel. that we have drawn a line that is parallel to AB and passing through origin. Without that, can be able to find direction cosine. Very, very important. See, in the very first definition of direction cosine, what we did is we have just drawn a line that is parallel to that. We have taken a point P, we have made alpha, beta, gamma, taken cosine, we have found direction cosine. Now, instead of doing that, we are going to find the direction cosine of this AB. Very important, right? Okay. How to find the direction cosine of a line joining 2 points, right? Joining 2 points. I'll write it down. I'll write the proof. Then I will explain more in detail, right? You will get more clarity after that. Let us say this point is some x1 comma y1 comma z1. Very important, right? For exam point of view, x1 y1 z1. Let's say this point is x2 y2 z2. So we need to find the direction cosine of the line AB, right? So what I'm going to do is let us form a right angle triangle here, right? Form a right angle triangle here. Okay. Now I'm going to project this AB on x-axis. I'm going to project A and B on x-axis. So what is the projection of A? So it will be somewhere around here, right? Let us call this point as some L. And again project the point B, right? Project the point B to the x-axis. Let us say this point is M, right? So L and M are projections of A and B. This is our origin. L and M are projections of A and B on x-axis, right? Okay. Now this is our angle alpha, right? This is our angle alpha. This is our direction cosine. Yes or no? See, if that lines are parallel means the angles will be same only, right? Okay. Now we need to find cos alpha, right? Cos alpha, cos beta, cos gamma. That is, we need to find cos alpha, cos beta, cos gamma, right? Assume this is our x-axis now, right? This is our x-axis, this is our y-axis, this is our z-axis, right? Okay. So we need to find cos alpha. Now, what about this distance? What about this distance? It is nothing but x1. Yes or no? This point is x1 comma y1 comma z1. That means it is moving x1 units to the x-axis, y1 units in the y-axis, and z1 units in z-axis. So this distance is x1, right? And what about this m? M is nothing but x2. So this distance is x2, right? Exam point of view, you just remember the formula. Exam point of view, you don't need this proof. Just remember the formula. But I'm just telling how the formula arrived. So this is x1, this is y2, right? Now what is uh, okay? Let us write it down. What we have did. You write in your own, right? L comma m is a projection of A and B on x-axis respectively. Alpha be the angle made it, and x1 OL is x1 and OM is x2, right? You know all this. Project let L let M let L comma M be the projections of A and B on x-axis respectively. And what is the length of OL? It is x1. And what is length of OM? It is x2. Right? Length of OM is x2. Now what is cos alpha? That is L, right? Now what is L? L is cos alpha adjacent divided by hypotenuse. Now adjacent is this, right? Now what is this distance? This is same as LM, right? This is same as LM. What is LM? X2 minus X1. Yes or no? What is the distance LM? Overall, it is X2. You need to subtract L1 to get LM. So adjacent is nothing but LM divided by hypotenuse. What is hypotenuse? It is nothing but length of AB. Right? So what is LM? LM is x2 minus x1. Yes or no? This is overall it is x2. We need to subtract this L1 to get this LM. So x2 minus x1 divided by length of AB. This is our L. This is our L. Now similarly, what is M? M will be cos beta. So again it will be adjacent by hypotenuse. In this case you will have y2 minus y1 divided by length of AB. And what about M? Similarly, you will have cos gamma adjacent by hypotenuse. See, we can easily visualize x and y, but for a z axis, we need to write similarly, right? Hard to visualize in 3D surface. So n is adjacent by hypotenuse, which is nothing but z2 minus z1 divided by length of AB. So therefore, very important. What is the direction cosine of a line joining 2 points? Of a line joining 2 points x1, y1, z1. Direction cosine of a line joining A and B, x2, y2, z2 is nothing but, so what is the direction cosine L comma M comma N? It is nothing but x2 minus x1 divided by length of AB, this is our L, y2 minus y1 divided by length of AB, which is our N, z2 minus z1 divided by length of AB. Now, what happens if your A is in origin? What happens if your A is in origin? What happens if your A is in origin? You will get the direction cosine formula. Yes or no? If this A is in origin means this will be 0 comma 0 comma 0. You will get the direction cosine this formula. Yes or no? That is, you will get this. L comma M comma N. You will get all these. Yes or no? X divided by root of x square plus y square plus z square. Y divided by root of x square plus y square plus z square. N is equal to z divided by root. You will get all these, right? So L is cos alpha. Cos alpha is same as x by root of x square plus y square plus z square. Yes or no? See, it will be x2 minus x1. X2 minus x1 divided by length of OP. Y2 minus y1 divided by length of OP. Z2 minus z1 divided by length of OP. Since this is origin, this is a formula we will have. This is very similar, right? This is very similar. This is a general case. This is general case. If A is in origin means you'll get the previous formulas, right? You'll get the previous formulas. So very important. So direction and cosine of a line joining 2 points is very simple. X2 minus x1, y2 minus y1, z2 minus z1 divided by length of AB, AB, AB. Yes, can we do some problems now? No doubt, right? As of now. So direction cosine of a line joining 2 points is very, very important. If this A point is 0 comma 0 comma 0, you will get the previous answers. Okay. So we move on to problems. So we will do two problems. As of now, don't know, right? If any doubt, I'll clear now itself. Okay, so no doubt. This session will be long, right? So adjust with it. Uh, I'll give you some 3 to 4 minutes break. So we'll do problems now. So find the direction cosine. Find the direction cosine. Find the direction cosine L comma M comma N of two lines which are connected by which are connected by the relations L minus 5m plus 3n is equal to 0 and 7l square plus 5m square minus 3n square is equal to 0. L minus 5m plus 3n, 7l square plus 5m square minus 3n square is equal to 0. It's a very important problem. So these are questions. These kinds of questions are asked in IFOS, but not in IAS still. So you can expect these kinds of questions, right? Okay, in IAS. Okay. So find the direction cosine of two lines. See, very simple, right? So we need to find the direction cosine of two lines. So we have our XYZ axis. So we need to find the direction cosine of two lines. This is our L1. This is our L2, right? Just for understanding, I'm just drawing simply. So we need to find direction cosine of this line as well as this line. So for this line, this is our alpha, this is our beta, this is our gamma. And for this line, this is our alpha, this is our beta, and this is our gamma. So this will have some L comma M comma N. This will be some L comma M comma N. Yes or no? So this will have this will have some L comma M comma N, and this will have some L comma M comma N. We need to find out. So there is this L comma M comma N and this L comma M comma N. There is a connection between these two. That what this is a connection. That is L minus 5m plus 3n is 0 and 7l square plus 5m square minus 3n square is 0. That what the connection is. So find the direction cosine of two lines which are connected by, that is L, that if I add L minus 5m plus 3n for both, it will be 0. 7l square plus 5m square minus 3n square is also 0, right? So we'll do very easy problem. You just have to solve for LMN, that's it. Just have to solve for LMN, that's it. So these kinds of problems are, you can expect these kinds of problem, right? So they have given two equations, right? L minus 5m plus 3n is equal to 0. Call this as 1. 7l square plus 5m square minus 3n square is 0. Call this as 2. You just have to solve these two equations for L, M, N. Okay, so from 1 we have L is equal to 5m minus 3n, right? Now put this L into, so from 2 we have 7l square plus 5m square minus 3n square is 0. So instead of L, I'm going to put 5m minus 3n whole square. You can do anything, right? I'm writing L in terms of mn. You can write n in terms of lm and you can substitute n here. You can do anything. So some 5m minus 3n whole square plus 5m square minus 3n square is 0. So 7 times, so a minus b whole square formula. So a square minus 2 times ab. 2 times ab. So it will be minus 30 times mn plus b square plus 5m square minus 3n square is equal to 0. So multiply inside, 7 2s are 14, 7 5s are 35. So it will be 175, right? So 175 m square, 210 mn, 7 9s are 63 n square plus 5m square minus 3n square is 0. So 175 plus 5 will be 180 m square minus 210 mn. 63 minus 3 will be 60 times n square. So if I take 30 outside, This will be 6m square minus 7 times mn plus n square is equal to 0. So 30 is not equal to 0. So that means this has to be 0. So we have 6m square minus 7 times mn plus n square is 0, right? Sorry, 60, not 30, right? 63 minus 60 is 60n square. So this will be 2n square. If we take 30 outside, we will have 2n square. Okay, 2n square. Now factorize this. So sum is minus 7, product is 12. So sum is minus 7, product is 12. So it is minus 3 minus 4. So this will be 6m square minus 3 times mn minus 4 times mn plus 2n square is 0. So I can take 3m outside here in this. If I take 3m outside, we will have 2m minus n. If I take 2n outside, we will have 2m minus n. You will always have in this pattern only, right? You will have, see here, you are writing L in terms of mn. That means you will have m square, n square, mn term only. In the exam point of view, you just make one, you just do it one method, right? Whatever you can do. But if you are writing L in terms of mn, that is here we are writing L in terms of mn and are substituting back here, right? So you will have m square term, n square term, and mn term, right? That is what you will have. Usually you will have. You have to factorize this. Now we will have 2m minus n into 3m minus 2n is 0. That means 2m minus n is equal to 0. 3m minus 2n is equal to 0. That means 2m has to be equal to n or 3m is equal to 2n. So we have two cases now. So for each of the case, we will find we have two case, right? This can be 0 or this can be 0. We will consider this as case 1, case 2. In case 1, we will find direction question of first line. In case 2, we can find direction question of second line. Okay. So first consider case 1. Case 1. Case 1, when 2m is equal to n. We need to find LMN, right? We need to find LMN. Okay. Very important step is this. Now what is L? By your assumption, L is 5m minus 3n. Now what is n? N is 2 times m, right? Three times n is 2m. So this will be minus m, right? Now we have L is equal to minus m. See, you just have to connect this. You just have to connect these two, right? You just have to connect these two. Very important. See, L is okay. You just have to connect these two, right? Very important stage. L is minus m. Minus m is minus n by 2. Is it correct? L is minus m, and from here m is n by 2. Is it clear? You just have to connect L, m, n by this equality. Is it clear? L is minus m, and minus m is n by 2. Or you can write minus L is equal to m. See, you can do anything, right? Or you can write, see, all are same only. So, or you can write minus L is equal to m, and m is n by 2, right? See, you should have L, m, n to be positive. So, I'm going to divide throughout by minus. With divide throughout by minus, we will have L by 1, m by minus 1, n by minus 2. What can you say about 1 minus 1 and minus 2. What can you say about 1 minus 1 and minus 2? I'm multiplying throughout by minus. What can you say about or we can write, okay, let us, okay, both are same only. So instead of that, let us write like this, right? So instead of, so in order to keep L positive, we can write like this itself, right? So L by minus 1, M by 1, N by 2. Okay, so you don't want to divide by minus, right? So just put L, you just take L to be positive, right? Minus 1 below. Now what can you say about minus 1, minus 1, 1, 2? Minus 1, yes, exactly. Minus 1, 1, 2 is the direction ratio of some line. First line or second line. So what we infer is in case 1, so minus, so what is the dr? So dr is minus 1, direction ratio is minus 1, 1, 2. How to find direction cosine? How to find direction cosine if you have direction ratio? You just have to divide by its, normalize this. So 1 square plus 1 square plus 2 square. So minus 1 divided by root of, so we will have 1 square plus 1 square plus 2 square. 2 square is 4, 4 plus, so we will have 6. We will have 2 by root 6. So minus 1 by root 6 plus 1 by root 6 minus 1 by root 6 plus 1 by root 6 plus 2 by root 6. This is our direction cosine of first line. So you can see from case 1, we have obtained direction cosine of first line, which is minus 1 by root 6, 1 by root 6, 2 by root 6. Right? See, there may be many lines. Okay, first I'll explain, write it down and then explain, right? So is it clear up to now, right? So from case 1, from this case, we need to obtain a relation, that is L is equal to M is equal to N. Yes, that is what I'm trying to say. Anitambol, just a minute. Give me a minute. I'll clear it out. That is what I was about to tell, but I will tell at the last. So this is our direction cosine of first line, right? Okay. Direction ratio need not be unique, right? So you can write that also. Okay, just a minute. Okay. Case 2. Now case 2 is 3m is equal to 2n. Now what is L? L is 5m minus 3n. So 5m minus 3 times. So what is n? N is 3m by 2. Right? N is 3m by 2. So this is 10 minus 5m minus 9m by 2, 10m minus 9m. So L is m by 2. L is m by 2, right? Okay. Now you need to connect L, m and n. You need to connect L, m and n. You need to connect these two. See, we have 2L is equal to m. And what is m? M is 3n by 3n by, sorry, 2n by 3. We should always have L, m, n here. We can divide by 2, right? By divide by 2, we will have L by 1, m by 2, n by 3. Yes or no? You should always have, you always try to bring L by A, M by B, N by C. Right? M by A, N by B, N by C. So divide by 2. So 2, 2 will get cancelled. We will have 2. If I divide by 2, 2, 2 will get cancelled. That means direction ratio of this line is 1, 2, 3. Direction ratio of this line is 1, 2 and 3, right? Direction ratio of this line is 1, 2 and 3. Now what about direction cosine? What about direction cosine? 1 divided by root of 1 square plus 2 square plus 3 square. So 9 plus 4, 9 plus 4 is 13, 13 plus 1 is 14. So 1 by root 14, 2 by root 14, 3 by root 14. This is our direction cosine of the second line. 1 by root 14, 2 by root 14, 3 by root 14. Right? Now you can see this will satisfy this relation. L minus 5 times n plus 3 times n. What about L minus 5m? So L is minus 5 times m is minus 5. See, this is minus L minus 5m. So minus 6 by root 6 plus 6 by root 6. You can see it is 0. It satisfies L minus 5m plus 3n is 0. And also both will satisfy these relations. Right? Yes. Now I come back to the question. Now if you write instead of minus 1, 1, 2, you can also write, if you divide by minus 1, you can also write 1 minus 1 minus 2. Yes or no? Instead of this, direction ratio need not be unique, right? Instead of this, if I divide throughout by minus 1 minus 1 minus 2, 1 minus 1 minus 2, for that you will have different direction cosine. So it is not that these are the only two lines that satisfies this relation. There can be many lines, right? There can be many lines that satisfies that relation. But we need to find the direction cosine of any two line, right? The answer need not be unique. That is why UPSC are not asking this question, these kinds of question here. So depending upon your direction ratio, direction cosine will change, right? So there are many lines whose direction cosine satisfy this, but we need to find any two lines. Answer need not be unique, right? That is why they are not, I think they are not asking, right? Okay. So is it clear, right? So I think you can do these kinds of problems, right? They will give, yeah, they will give some L comma M comma N and repeat. Okay, what I need to repeat? See, this is the direction ratio here is minus 1, 1, 2. Instead of this direction ratio, if I divide throughout by minus 1, this will be plus 1 minus 1 minus 2. You will have 1 minus 1, 2, right? Just a minute. Okay. See, here we are having minus 1, 1, 2 as our direction ratio. Instead of this, if I divide by minus, you will have 1 minus 1 minus 2 as our direction ratio. For this, your direction cosine is 1 by root 6 minus 1 by root 6 minus 2 by root 6. See, you are getting different line because this has different direction ratio, right? What I'm saying is there is not only two lines that satisfy that relation, there are many lines that satisfy that relation. But we need to find any two lines only. For that, you are finding the direction cosine of two lines. Is it clear, right? Ah, yes, many lines exist. And what the next problem? A similar problem, problem 2. So find the direction cosine. Find the direction cosine. Find the direction cosine L comma M comma N of two lines which are connected by the relation L plus M plus N is equal to 0 and Mn minus 2 times NL minus 2 times Lm is equal to 0. So just try this problem. Same problem. I just changed only the coefficients of. So just do this problem. I'll just take 2 minutes break. Yes, so I think you would have solved, right? I'll do this fast. So we have L plus M plus N to be 0. Mark this as equation number 1. And we have Mn minus 2 times NL minus 2 times Lm is 0. Mark this as equation number 2. Now from 1 we have L is equal to minus M minus N. So substitute into, so 2 is Mn minus 2 times NL minus 2 times Lm is 0. So Mn minus 2 times, so L is minus M minus N. L is minus M minus N is equal to 0. So Mn minus, sorry, plus 2Mn plus 2n square plus 2m square plus 2 times Mn is 0. So we have 2m square, 2m plus 2m. So we will have 4 times Mn, sorry, 2m square, 5 times Mn. 5 times Mn plus 2 times n square is 0. So factorize this now. So sum is 5, product is 4, 1 4, right? So we will have 2m square plus plus mn plus mn plus 4 times mn plus 2n square is 0. Now if I take m common, we will have 2m plus n. If I take 2n common here, we will have m plus 2m plus n, right? If I take 2n common, we will have 2m plus n. So we will have m plus 2n into 2m plus n is equal to 0. So we will have two cases now. So case one is m plus 2n is equal to 0, and case 2 is 2m plus n is 0. 5mn, yes, okay. So case 1, so case 1 is m plus 2n is 0. M plus 2n is 0. So that means m is equal to minus 2 times n. And what about L? L is minus m minus n. So minus m, we will have 2n minus n. So we have L is equal to n, right? L is equal to n. M is minus 2n. So it should be plus 2n. Okay. Now we can see L is same as n, and n is minus m by 2, right? So we will have L by 1, m by minus 2, n by 1. So direction ratio is 1 minus 2 1. So our direction cosine will be 1 divided by root 6 minus 2 divided by root 6, 1 divided by root 6, right? I'm just interchanging this. So m by minus 2. So 1 minus 2 1. So this is our direction ratios, right? Okay. Now case 2 is 2m plus n is 0. 2m plus n is 0. So that means 2m is equal to minus n. So that means m is minus n by 2. And we know what is L. L is minus m minus n. So minus m is plus n by 2 minus n. So minus n by 2. So L is minus n by 2. See, you can connect these two very easily, right? L is minus n by 2 and minus n by 2 is m. So we will have L by 1, m by 1, n by minus 2. So 1 1 minus 2. 1 1 minus 2 is the direction ratio of second line. So direction cosine will be 1 by root 6, 1 by root 6 minus 2 by root 6. You just have to 1 divided by root of a square plus b square plus c square. So 1 by 1 square plus 1 square plus minus 2 square. So 1 by root 6, 1 by root 6 minus 2 by root 6. So this is our direction cosine of the two lines. So 1 by root 6 minus 2 by root 6, 1 by root 6, 1 by root 6, 1 by root 6 minus 2 by root 6. Right? So this is our answer. This is our direction cosine of two lines. Okay, so we'll move on to next concept. Angle between the two lines, right? The angle between the two lines, if the direction cosines are known. Angle between the two lines. Next topic. Angle between two lines if direction cosines are known. So we have two lines, L1 and L2, right? So if I know direction cosine of two lines, so let us say this. Let us say the first line has direction cos. Let us say the first line has direction ratio L1, M1, N1, and the second line has direction ratio L2, M2, N2, right? L2, M2, N2. Now we need to find the angle between the two lines, theta. If you know direction cosine of line, that is given by cos theta is equal to L1 L2. See again, you just have to extend 2D idea. What about angle between the two vectors? It is A dot B by, you know, very easy formula, right? Angle between the two vector in 2D. You will see this formula, right? Cos theta is equal to A dot B dot product divided by modulus of A vector modulus of B vector. This is what you will study in 11th standard vector algebra. Angle between the two vector A dot B by mod A mod B. And see, since here both are what? See, A dot B will be L1 L2 L1 L2 plus M1 M2 plus N1 N2 divided by magnitude of first vector magnitude of second vector. And since the direction cosine is a unit vector, so therefore this will be 1 1. Yes or no? See, this is a unit vector, yes or no? L1I vector plus M1J vector. See, divided by root of L square, L1 square, M1 square, N1 square, this is always 1 into root of L2 square, M2 square, N2 square, which is again 1 only. This is the angle between the two line. If you know direction cosine of the two line. Angle between the two line, if direction ratios are known, you can write easily, right? Angle between two lines, if direction ratio are known. So what about the formula? Very easy, right? So you have L1, you have L2. This has direction ratio A1, B1, C1, and this has direction ratio A2, B2, C2. What about the angle between two lines? Cos theta is equal to dot product A1, A2 plus B1, B2 plus C1, C2 divided by magnitude of first vector, so root of A1 square, B1 square, C1 square into root of second magnitude A2 square, B2 square, C2 square. So here we will write, see here you will have divided by root of L1 square, M1 square, N1 square, which is 1 because it's a unit vector, and we also already proved that L square plus M square plus N square is always equal to 1. So this is how to find angle between the two lines if direction ratios are known, if direction cosine are known. See, here you will have divided by root of L1 square, M1 square, N1 square into root of L2 square plus M2 square plus N2 square. And we know this is always equal to 1. That is why this is a unit vector also. So I am not writing that. 1 into 1 we will have the denominator. This need not be 1, right? Because this is direction ratio only. So this is our the angle between the two lines if direction ratios are known. Okay. Now uh, two lines will be two lines are perpendicular. What is the condition? Two lines are perpendicular means your theta will be 90 degree. So if your theta is 90 means cos 90 is 0, cos 90 is 0. So two lines are perpendicular if L1 L2 plus M1 M2 plus n1 n2 is equal to 0. This happens, then we say two lines are perpendicular. This is in terms of direction cosine. In terms of direction ratio, a1 a2 plus b1 b2 plus c1 c2 has to be 0. Yes or no? This is in terms of dc, in terms of dc, in terms of dr. See, if theta is 90 means cos 90. Cos 90 is 0. Here also 0. So multiply this with 0. So you will have a1 a2 plus b1 b2 plus c1 c2 is 0. So if you are getting L1 L2 plus M1 M2 plus N1 N2 is 0, you say that the two lines are perpendicular. Now two lines are parallel. Two lines are parallel. So two lines are parallel in terms of direction cosine. It will be same. L1 is same as L2. M1 is same as M2. N1 is same as M2. In terms of direction cosine, in terms of direction ratio, they are proportional. A1 by A2, B1 by B2, C1 by C2. In terms of DR, in terms of DC. See, very important, these two are. This is the condition in terms of direction cosine, in terms of direction ratio. See, very important slide this is. So, angle between the two lines, if direction cosines are known, angle between the two lines, if direction ratios are known. Okay, now we'll do some problems. That's not no doubt, right? Problem. Problem 3. Show that the direction, show that the lines, show that the lines whose direction cosines, whose direction cosines are given by the equations, are given by the equations 2L plus 2M minus N is equal to 0 and Mn plus NL plus Lm is equal to 0 are at right angles. This is similar to the previous problems. Show that the lines whose direction cosines are given by this relation are at right angles. Very easy. You just have to find the direction cosine for two lines as previous. So find L1 M1 N1, find L2 M2 N2, make a dot product L1 L2 plus M1 M2 plus N1 N2. If it is equal to 0 means then you can say they are at right angles. Very easy. Yes or no? So same as the previous, you just find the direction cosine of two lines as previous. After that you will have DC of first line, DC of second line. So L1 M1 N1, L2 M2 N2. So you just make a dot product, you just say this condition satisfies, then you can say that They aren't right angles. Okay. Okay. Show the light. Okay. So usually we will write L in terms of Mn, but here we will write N in terms of Lm, because if I write L in terms of Mn means we will have some denominator and so on, right? You can write anything. Let us write N to be equal to 2L plus 2M, right? Call this as 1. Now substitute N value here. So we have from 2Mn plus N times L plus L times L is 0. I'm going to replace N to be this 2L plus 2M, 2L plus 2M into L plus Lm is equal to 0. So 2 times Ml plus 2 times M square, 2 times L square plus 2 times Ml plus Lm is equal to 0. So we have 2M square plus same as the one 2L plus 2M minus. I are getting the same equations, right? 2M square 5Mn n 2, but it is sum of Lm. Okay, so 2M square plus 5 times Ml plus 2 times L square is 0. Okay. From now on, I think you can do anything. You can do this problem, right? Okay. So factorize this. So we will have 2M square. Sum is 5. Product is 4. So 1 4s are. So ML plus 4 times ML plus 2L square is 0. So take M common. So we will have 2M plus L. 2M plus L, and again if I take 2 times L common, we will have 2M plus L is equal to 0. So we will have M plus 2L, 2M plus L is 0. So we will have case 1 and case 2. So depending on case 1 and case 2, find direction cosine of both the lines. So case 1 is M plus 2L is equal to 0. That means your M is minus 2 times L. And what is N? N is 2L plus 2M. So 2L is minus M. Right? 2L is minus M. So this is M. So N is same as M. And M is minus 2 times L. So we have minus 2L is equal to M. And M is same as N. So this is same as L by minus 2, M by 1, N by 1. So direction ratio of the first line is minus 2, 1, 1. So direction cosine is minus 2 by root 6, 1 by root 6, 1 by root 6. Right? And similarly for case 2, you find direction cosine of second line. So case 2 is 2M plus L is 0. So we have 2M is equal to minus L, and we know N is 2L plus 2M. So 2M is minus L. So N is same as L. So we have minus 2M is equal to L, and L is same as N. So we will have M by minus 2 L2. Sorry, just a minute. You should not write like this, right? Sorry. See, they are not proportional, right? We have to divide by 2. Sorry. Yeah, we can write this as 1 by 2. 1 by 2, right? Not minus 2, sorry. Okay, so instead of that, what we can do is, sorry, we can you can write minus 1 by 2, but instead of that, what we'll do is we will divide throughout by 2. We will divide throughout by 2. So we will have, if we divide by 2, we will have L by minus 1, M by 2, N by 2. Right? If you want, you can write L by minus 1 by 2, but you should not write L by 2. Sorry, both are not same. So that means the direction ratio of the first line is minus 1 to 2. So our direction cosine is minus 1 by root of 2 square plus 2 square plus 1. So 4 plus 4 plus 1. So it will be 3. So minus 1 by 3, 2 by 3, 2 by 3 is our direction cosine of first line. Sorry. And here we have m, we have m to be L. Okay, we have L to be minus 2m. Okay, we have to connect L, M, and N, right? Okay. And we know this is equal to N, right? Because L is equal to N. So we have 2m is equal to minus L, m is minus L by 2. So we have N and L are same. L is yes, L is minus 2m and L and N are same only. Okay. So divide by 2, right? Divide by 2. Divide by 2. So therefore this direction ratio is 2 minus 1 2. So direction cosine will be 2 by 3 minus 1 by 3, 2 by 3, right? So 2 divided by root of 2 square plus 1 square plus 1 square. So it will be root 9. Root 9 is 3. Okay. Here I am dividing by 2. Here also I am dividing by 2. Now you make a dot product, right? This is our L1, this is our M1, this is our N1, this is our L2, this is our M2, this is our N2. So we have L1, L2 plus M1, M2 plus N1, N2. Now what is L1, L2? Minus 1 by 3, 2 by 3. So it is minus 2 by 9. M1, M2. 2 by 3 minus 1 by 3. Minus 2 by 9, right? N1, N2 will be 4 by 9. So this is minus 4 by 9 plus 4 by 9, which is 0. So therefore they are perpendicular. They are perpendicular. That means theta is 90 degree. So therefore they are at right angles. Sorry. You just have to divide by 2. Yes. Is it clear? See, same as previous, we have stopped at this stage in the previous problems. Here we need to show that they are right angles also. So that means you just make a dot product. We know two angles, two lines will be at right angles in terms of direction cosine. L1, L2 plus M1, M2 plus N1, N2 is 0, right? Okay. So we will do last problem and then we'll wind up this video. So we will do one previous year's questions from IFOS. I have said there are 4 questions, right, from IFOS from this topic. One question we are going to do now. Uh, Find the angle between lines. Find the angle between the lines whose direction cosines are given by the relation L plus m plus n is equal to 0 and 2Lm plus 2Ln minus Mn is equal to 0. 2017. I think we have did the same problem. L plus m plus n 0, 2L plus 2Ln minus Mn. 2L, I think this is same as that problem, right? You multiply by minus, you will get that question. 2L multiply by minus, we will have 2L plus 2Ln. Yes, I think both are same problem, but they are asking you to find direction. Sorry, they are asking you to find the angle between the two line, right? Angle between the two line. So I think you will get the same direction cosine. This will be the direction cosine. Now find the angle. Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. You will get the answer. Do I need to do this or solve this, or you can do in your own, right? So find L1 L1 N, find L1 M1 N1 L2 M2 N2. I think the same answer you will get for the first problem we have did, right? After that, make use of the formula cos theta is equal to, make use of this formula. Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. So we will have theta to be cos inverse of this. So the angle is theta is equal to, we have theta is equal to cos inverse of this L1 L2 M1 M2 N1 N2. Right. So if these values are known means you can find it. For example, 1 by 2, root 3 by 2. For that, you can easily find that. If not, you just write that value as it is. See, if you are getting 1 by 2 means you can write it as, if you are getting 1 by root 2 means you can write it as 45-degree, right? If you are getting root 3 by 2 as, you can write 60-degree. If some other term means you just keep that as it is. You can do this problem, right? I think I don't want to. Okay, you are getting minus 1 by 2. Okay, so that means your cos theta, that is theta is cos inverse of minus 1 by 2. So cos inverse of minus 1 by 2 is same as pi minus pi by 2. So it is 150 degree, yes. Tangents and cosines are same only, right? Multiply by, if I take minus outside and equal to 0, this problem will turn out to be the first problem. Our first problem we have already done, we have already found the direction cosines of both the lines. You will get someone, Krishna Shah is saying it will be cos inverse of minus 1 by 2. You just check your answers. See, um, if you are taking modulus here means you are taking acute angle. If you are keeping this as it is means you are taking obtuse angle. So in exam point of view, the answer key can be acute angle as well as in obtuse angle, right? If you are taking modulus for this means you are taking acute angle. For example, if you are getting minus 1 by 2 here means if you take acute angle means it will be if you want to take modulus that means it will be 1 by 2. So cos theta is equal to 1 by 2 means theta will be 60 degree, right? If you are taking obtuse angle means you don't need to take modulus. So you will have minus 1 by 2. So minus 1 by 2 is same as pi minus pi by 3. So pi minus pi by 3 is 2 pi by 3. So obtuse angle is 2 pi by 3. Acute angle is pi by 3. Is it clear? Or do you want to repeat? See, if you are taking modulus means you will have cos theta to be 1 by 2. Acute angle means what is our so you will have direction cosines of first line and second line to be what is the direction cosine? We have already done this, right? First problem L plus second problem L plus M. So what is the direction cosine is? Or you can also take direction ratio also. You need to apply that formula. So 1 minus 2 1 1 minus 2 1 2 1 1. This is what you will get direction cosines. This is what you will take. You will get as direction cosines. 1 minus 2 1 1 minus 1 and 2, right? 1 2 minus. Now you make use of the formula, right? Cos theta is equal to L1 L2 plus M1 M2 plus N1 N2. You will get the same answer only, I think, right? Because both are same only. So you will have so 1 by root 6, 1 by root 6 is plus 1 by 6 minus 2 by 6 minus 2 by 6. So this will be minus 3 by 6. This will be minus 1 by 2. So if it is acute angle means if it is acute angle means you take modulus. So that means cos theta is equal to 1 by 2. So theta is cos inverse of 1 by 2. Cos 60 is 1 by 2. So pi by 3. And if it is obtuse angle means you don't need to take modulus. So cos theta will be minus 1 by 2. So theta is cos inverse of, so I can write minus 1 by 2 as pi minus pi by 3, right? Because if you have minus means you have to write pi minus cos 60 because what is pi minus pi by 3? So pi will be here, so pi minus will be here, so here cos is negative, so we will have minus cos pi by 3. So minus cos pi by 3 is minus 1 by 2. So that means this is, sorry, right? Cos theta is equal to, I can write minus 1 by 2 as pi minus pi by 3. Cos of pi minus pi by 3, that means theta is 2 pi by 3. Right? So if it is acute means you can go that. If it is obtuse means you can do that. Is it clear? In the exam point of view, take modulus and show that is an acute. Uh, if it is obtuse means don't take modulus, right? This is very easy, right? This is around just 11th standard trigonometry. I can write minus 1 by 2 as cos pi minus pi by 3. So theta is 2 pi by 3 and this is pi by 3. Acute angle, obtuse angle. Okay, so that's it. So we'll stop here. So in this class, what we did is we have introduced direction cosine of a line. So very simple. Um, it is nothing but the angle made by that line on xyz axis and take cosine of those angles. That is called direction cosine. And the direction ratios are nothing but any number that is proportional direction cosine is called direction ratio. To obtain direction cosine from direction ratio means you have to normalize each coordinates. After that, we have seen some problems. After that, you introduce angle between the two lines if direction cosines are known, if direction ratios are known, and then we have solved two problems based on this. Right? Is there any doubt? Any doubt? Any doubt? We will address this, or else we will wind off this session. So tomorrow we will be solving more problems based on this. In one two more classes we will be completing direction cosine direction ratios. Right? Maximum two more classes. After that we will start planes, right? Planes and then straight lines and so on. Is there any doubt? No doubt, right? So I'll update about the timings of the next class in Telegram group. So if you haven't joined Telegram group, join Telegram group for class updates, right? So thank you. I'll upload this PDF notes in Telegram group after this session. We'll continue in the next class, right? Thank you. All the best. The book I am following solid PNC solid geometry. PNC solid geometry. As of now, just follow my notes. I'll send practice questions from the book. If not today, from the next session. Okay, thank you.